plotting points and finding coordinates. Example number 3. Graph a line parallel to the given line through the point provided. Here's the point provided. Plot at least 2 other points with integral coordinates. Integral coordinates mean they cross at a vertical and horizontal line, kind of like this point right here on the line and this point right here on the line have integral coordinates. This point would not, because it only crosses through a vertical line, not also a horizontal line. So remember, when we're finding a line that is parallel, we want to think it needs the same slope. So let's start by finding the slope of the given line. From one point on the left to the point on the right, I count the slope down 1 and then over 2. So if I'm using this point, because it says it has to go through the point, then I'll start here and I'll count the same slope, down 1 and over 2, and then I put another point. Now it says plot at least 2 other points, so I could do it again, down 1 over 2 and plot another point. But if I run out of room or need more points, I could go backwards. Backwards of down 1 is up 1, backwards of right 2 is left 2, and then I find another point. I can always check by grabbing my ruler and making sure that the points line up. I could also grab my ruler to make sure that the lines are parallel. So once I have my ruler, using my straight edge, I can graph that line that would be on the line that's parallel to that given line. Now, remember that when I graph a line, I would put arrowheads. But notice the main point of what it says is plot at least 2 other points. Now it's said to graph a line, so I'll put those arrowheads. Let's take a look at the other one. Graph a line perpendicular to the given line through the point provided. Plot at least 2 other points with integral coordinates. Notice this line is like this line. So when I find the points with integral coordinates, I'm going to be counting the same slope, -1 and over 2. But remember that a perpendicular line has a slope that is the opposite reciprocal. So if this line has a slope that is -1 over 2, my line that is perpendicular will have a slope that is not negative but positive, not 1 over 2, but 2 over 1. So from this point, I would go up 2 and over 1. There's my next point. Now I've run out of room to keep going, so I'll have to go backwards. Opposite of up 2 is down 2 and then left 1. Down 2 and left 1. I could do that many more times because I still have room. Then I can graph that line. Now remember, if the line is perpendicular, we can help use our ruler to make sure that it is perpendicular. See how I line up my ruler so that one edge is on the line provided and the other will be going through the point that they gave me. There's one edge of the ruler and the other edge of the ruler lines up with those points. Now I'm going to use my ruler as a straight edge to draw my line. And we'll remember to draw our arrowheads. Number 5. Find the value of x so that the line passing through the 2 points has the given slope. Here's the value of x that is unknown. Here's the given slope. Remember, the slope formula is y2 minus y sub 1 over x sub 2 minus x sub 1. So I could put these x and y coordinates, this is point 1 and this is point 2, into my formula with the slope being 3. Now, it would be easier if the x, the unknown, goes first. So I'm going to switch these around. So this point is point number 2, as long as I switch it for both the x and the y. And this is point number 1. So the slope is 3. 3 equals y sub 2 is negative 7 minus y sub 1 is 2 divided by x sub 2 is x minus x sub 1 is 1. How do I solve this kind of equation? Well, if this is a 3, it's like it says 3 over 1, and then I can multiply both sides by this denominator, or cross multiply. 3 multiplied to x minus 1 looks like this. 3 times the quantity x minus 1 equals 1 is in the denominator here, so it gets multiplied over there. 1 times the quantity, negative 7 minus 2. On the left side of the equation, I can distribute 3x minus 3 equals, on the right side of the equation, I don't have to distribute because these can be combined. Negative 7 minus 2 is negative 9, and 1 times negative 9 is negative 9. Then I can continue to solve this equation. Draw the line at my equal sign, add 3 to both sides. 3x equals negative 6, divide by 3, and x equals negative 2. That's one way to do it. Now, I gave you a piece of graph paper because another way to do it is to graph it. Let's start by graphing the point that we know, 1, 2. 1, 2. That's this point. Now I'm going to use the slope, which is 3 over 1, to find some other points. Up 3 over 1, up 3 over 1. Now let's go backwards because we've run out of room. Down 3, left 1. Down 3, left 1. Down 3, left 1. Now I have no more room. Notice that this point has the y-coordinate of negative 7. So on the y-axis, 1, 2, 3, 4, 5, 6, 7, here's negative 7. Here is the point that goes with it. What is the x-coordinate? On the x-axis, 1, 2, negative 2. So now I can tell from the graph that the x-coordinate is negative 2, because this is the point, negative 2, negative 7, that lines up with my other points. You may do it either way. Let's take a look at a couple more examples. Number 6. Given a line that passes through points A, 1, 5, and B, 2, 3, plot points P, negative 3, 1, and Q, negative 4, n, so we have to plot these points, that make up a line parallel to line AB. Remember that parallel means same slope. When we see that word, we should write that down. Let's start by plotting this point because we have both coordinates. Negative 3, up 1. There's point P. Q, however, I don't know. So let's go back to the points that make up line AB. A is 1, 5. Let's plot that. Over 1 and 1, 2, 3, 4, 5. And B is 2, 3. 1, 2, 1, 2, 3. There's B and there's A. So the line contains these points. Now remember, we said it has to have the same slope. So what's the slope of line AB? Let's count it out. From left to right, down 2, and to the right 1. So the slope of AB is negative 2 over 1. We want the exact same slope for the line that has points P and Q. So from point P, let's count down 2 and over 1. And there's the next point. Let's keep doing that. Down 2 and over 1. Down 2 and over 1. Now they specifically want point Q that is at the x-coordinate of -4. 1, 2, 3, 4. But we don't have a point there, so we need to do our slope backwards. Instead of down 2, up 2, and left 1. Now there is point Q because that has the x value -4. What is the y value that is missing? Well, let's count up. 1, 2, 3. That's the y value 3. Q is at -4, 3. So the n value we're looking for is 3. There is the point we were supposed to plot, and there is our value for n. Number 7. The slope of line P is -2. Given points A, 5, -1, and B, 3, n, find the value of n. This is our goal. Find the value of n. So that line AB is perpendicular to line P. Perpendicular, remember that means the slope is the opposite reciprocal. So if the slope of line P is -2, the slope of our perpendicular line is positive. Remember that -2 is like -2 over 1, so ours is positive 1 over 2. Now the last time we did this with a graph, but we don't have to do it with the graph. We can do it with our slope formula. Remember that our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Here is our slope that we can plug into our equation. So 1/2 equals, and here are our 2 points, x and y and x and y. This is our first point and our second point, if we'd like to go in that order. We start with the y's, so n minus -1 over 3 minus 5. Let's simplify this a little bit. 1/2 equals n minus -1 means n plus 1. 3 minus 5 means -2. Now we can cross multiply. 1 times -2 is -2 equals 2 times the quantity n plus 1. Then we will distribute. -2 equals 2n plus 2. If it's easier, switch sides so that all of the stuff here with the variable is on the other side. If that's easier for you, I'm going to continue to solve. -2 on both sides, subtracting 2, leaves us with -4 equals 2n. And then we divide both sides by 2. So n equals, see n is by itself, -4 divided by 2 is -2. N is -2. They told us find the value of n, and we've done that. Thanks for watching.